Hello, a Rosie math teacher coming at you from my second period grade 7 math class, where today we are talking about lesson 7-3, area of polygons. Before we start on today's lesson, because it has to do with area of many different polygons, I wanted to show you a copy of this side of your fast exam math reference sheet that you will be supplied with during your PM3 at the end of this school year. It allows you to look at different formulas that you might need. Right now, I want you to write down for yourself the formula that we've already learned this week for area of a parallelogram. Please write this one down right now. It says, parallelogram, A equals BH. Now, I have a question for you. You might think it's a tricky question, but it's not. Is a rectangle also a parallelogram? Yes or no? Do you know? Yes, it is. What are the rules of a parallelogram? A parallelogram simply means that your opposing sides, I'll show you guys an example. Your opposing sides should be parallel with each other. Do you agree that in my red shape, the left and right lines run parallel to each other? Yes? Do the top and bottom lines run parallel to each other? Yes. So are both pairs of opposite sides parallel lines? That's what makes it called a, say the word with me, parallelogram. Try it again, I didn't hear you. Parallelogram. Now, let's take a look at what you are accustomed to calling a rectangle. Again, let's check with the definition of parallelogram. Are the top and bottom lines running parallel to each other? Yes or no? Yes. Are the left and right lines running parallel to each other? Yes or no? So technically, is it therefore also a parallelogram? Yes. Okay, what is the only difference? When a parallelogram shifts into the shape of a rectangle, the only difference is found in the what, class? In the corners. What do you notice about the number of degrees of every angle inside of a rectangle? They are always a right angle, which means they are always, does anyone remember? 90 degrees. Excellent. I heard it over here. So as soon as it is a four-sided parallelogram with all 90-degree right angles, then you know it has now become a rectangle, but it still could technically be called a parallelogram. I look at it as a specialized form of parallelogram because the parallelogram, this one, cannot be called a rectangle because it does not have the what? 90-degree angles. Now, they do not give you a formula that you're going to need today. They do give you, however, the trapezoid formula that we worked on yesterday. I'll have you write that in a moment when we are ready to do some of the homework. However, I do want you to write this down. It is not on your reference sheet, and you must remember how to do this. So go ahead and draw a rectangle. Draw a rectangle. They are never going to give you the formula for area of a triangle, so I want to show you a way that will help you to remember it. Okay, I will be right back. I have to handle something with a student. I'll be right back. Okay, I don't have room to write a name on list over there, so it will be here. Please keep your head up and look like you are trying to listen and trying to learn. Okay, now that we are all busy and listening, please draw this rectangle. How would you find the area of that rectangle, class? You would multiply base times height. Are we good with that? Now, draw a diagonal line so that your rectangle becomes two separate what? Okay, I'll trace one of those shapes in all black. You've known the name of this black shape for a very long time. Please say it. Triangle. What do you notice about the area of the triangle compared to the area of the rectangle?
It's not 90 degrees.
Okay, you can tell that some of these angles are not 90 degrees. This one is. But what do you notice about that area? Remember earlier we said the area of a rectangle is base times height. Yes? If I had to put a fraction in front of base times height or in front of length times width, to give myself the area of a triangle, what fraction would you pick?
1/2.
Excellent. I'm hearing it from a few people. So class, please draw an arrow to your triangle section and make yourself memorize the following rule. Area of a triangle equals, say that fraction again, class. 1/2, and let's use BH. 1/2 base times height. Does it make sense? Because didn't we cut that rectangle in half? Giving us a long side of our triangle, giving us the base and the height as the two shorter sides of the triangle, showing us that if we took the base and the height and multiplied it times 1/2, we would get the area of which piece? The rectangle or the triangle? Please say it. The triangle. Excellent. You need this formula. Have you all written it down? You need it for today's work. All right, now we are ready to talk about page 125. We are doing lesson 7-3, area of polygons. Guys, polygons are the many different shapes that can have different numbers of sides. Can you have a 3-sided polygon? We just did. What was it called? Triangle. Can you have a 4-sided polygon? Yes. The one that we did with the right angles was a rectangle. Excellent. Anyone know what you call a 5-sided polygon? Pentagon, just like the building in Washington, D.C. Anybody know the name of a 6-sided polygon? Hexagon. Anybody know what a stop sign is? How many sides does a stop sign have? 8, so it's an octagon. You're catching on. All right, let's start halfway down the page. Learn area of regular polygons. Everybody following both in your book and on the screen as I read. To find the area of a regular polygon, please underline regular polygon. Everybody mark regular polygon. Now, what does the word regular mean? I see some students that are not quite on their correct page. Can everyone in this room please go to page 125? Thank you so much. All right, on page 125, can we all please mark the words? What did I read to you? Regular polygon. Now, you realize you could have a regular polygon or you could have an irregular polygon. I'll give you an example. This would be called, it's a triangle, but to keep things simple, this would be called a regular polygon because all 3 sides and all 3 angles are all what? Same or different? Same. What's the big mathy word that means same? Congruent. What's the big mathy word that means same? Congruent. Each angle is congruent to the other angles. Each side is congruent to the other sides. And so you would give it little marks that all match. All right, but if I drew a triangle that looked like this, it is not a regular triangle. I see someone making a face. They really do not like my terrible triangle. You are correct. It is terrible. But I think I get the idea across that it has all different length of sides, doesn't it? If I used my little marks to mark the sides, they would look like this. This would get marked with 1 hash, this with 2, this with 3. What do those marks indicate to you? That every single measured side is same or different? Different. Are you following the difference between a regular polygon and an irregular polygon? Okay, regular polygon if all sides are, use the big math word, congruent. Irregular if we don't have all sides and angles being congruent. Okay, let's move on to what they're saying in this paragraph. And then they describe it. A polygon in which all sides are congruent. Please underline that as well, class. A polygon in which all sides are what? Say that word again. Congruent. And all angles are congruent. Underline that. You can decompose the figure. Ooh, let's see what they're saying here. Decompose the figure into triangles, parallelograms, or trapezoids. So out to the side, draw yourself some shapes that you could break it down into triangles, parallelograms, or trapezoids. So guys, we're basically on the hunt for these shapes being used together to form a new and different polygon. You'll understand this better as we practice. Find the area of each smaller figure and then add or multiply to find the total area. For example, you can find the area of the hexagon shown below by decomposing into smaller figures. So take a look at this hexagon. It is a regular hexagon, meaning that this side, which is how long? 2 centimeters. Go ahead and label the next side for how long you think that will be, based on the knowledge that it is a regular polygon. Therefore, it is a regular hexagon. Therefore, all sides are what? Congruent. So what measurement will I write on this next side? 2 centimeters. Please go around your shape and continue to write what you think the measurement of each side ought to be. And I will continue to mark it on mine. That side is also 2 centimeters. Next side is also 2 centimeters. Next side is also what, class? 2 centimeters. And finally, my last side is also 2 centimeters. Are you understanding that every time it is a regular polygon, every side will be the same as all the other sides? And that math word is congruent. Great, we're getting much better at that. Now, when I look at a hexagon, I see right away that if I trace over that center dotted line, go ahead and trace over that center dotted line, please. Do you see that you have 2 shapes you are familiar with? What are those 2 shapes? Name them. Trapezoids. I did hear one person say that. Thank you so much. All right, I want everyone in this room to take a look at the A equals 1/2 H multiplied times base 1 plus base 2. Do you recognize the formula used yesterday for finding area of trapezoids? Yes. So let's check to see what they did using that formula. In fact, let's go ahead and recopy it. And yesterday we had the base coming right after the 1/2. We're going to copy exactly how they show it on your reference sheet. So A equals 1/2 multiplied times height, and then the sum of the 2 bases. And it doesn't matter what order we put the bases in. Class, please write this in the white space that you have. A equals 1/2 H, and then in parentheses base 1 plus base 2. Now, do we know the full area of this shape yet? Do we know it yet? No. But can we use this formula to find the area of one trapezoid inside the shape? Yes. So let's go ahead and do that. Do we know the area yet? No. So please draw an answer box where you will be writing the area in a moment. Then your equal sign. What is the first thing I will copy? Say it. I should hear some voices. Guys, this is not hard. Please tell me what I am copying next. 1/2. Thank you. Do we have a height indicated by a line that is running perpendicular to a trapezoid base? Yes. What is the height? Read it. 1.73. So what shall I write next inside of parentheses? 1.73. You write it as well. Inside of parentheses, so in a moment, your calculator would know to multiply. Are we good so far? All right, now we need a new set of parentheses. Go back to the trapezoid we are currently working with. Do you immediately see one of the 2 bases? What is the smaller base? Tell me that one first. 2. It is 2. Please write a 2 as one of the base measurements. What is the other base? It is 4. Does everyone see the other base, the longer base of 4? So plug that in after your plus sign. And if we entered this into our online calculators, notice that at first we would get the amount they have right here, 5.19. Do you understand what you would have put into your calculator in order to get, write that in the box please, 5.19. Now, go back to your trapezoid and please write the 5.19 inside of what? Each trapezoid. So please write that area 5.19 inside your top trapezoid. Then please write 5.19 inside your lower trapezoid. And then tell me, should I add, subtract, multiply, or divide? You have 2 options. There are 2 different ways you could do this. What do you think we should do? Yell it out. Add. I hear some people saying add. So if we add, what numbers will we add? Excellent. Correct. We would add 5.19 plus 5.19 equaling a final total of 10.38. And it would be what? Centimeters or centimeters squared? Centimeters squared. Remember, area is squarea. Now, what is one other way we could have solved that? Raise your hand if you don't mind me pointing at you and letting you tell us. Go ahead. We could have multiplied. We would have done 5.19 times what? 2. Excellent. Do I have any questions on the other way you could have solved this? Okay, I want everybody sticking with me. Go to the very next page. Oh, look, there's that stop sign we talked about. Find area of regular polygons, just like the stop sign below. The stop sign below, they tell you, is a regular what? Say it, class. Octagon. What does the word octagon mean? 8 sides. What does the word regular mean? Every side is what? Oh, I like the big math word I heard over here. All the sides are? Congruent. Excellent. So if one side of the stop sign is 15 inches, what side are all the other sides of the stop sign? What length? 15. Just go ahead and quickly write a 15 by each side just to remind your brain. 15, 15, 15, 15. Now, you know Miss Rosie is always trying to think of another thing you might need to remember down the road. And I'll go ahead and trace that 15 so everybody on the TV screen can see it. When I look at 15 all the way around, if I were trying to find the perimeter, the distance around an object, what would I do with all of these 15s? Add them all up. So it would be 15 plus 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 15. How many times would I add 15 up?
7.
I would add it up 8 times because there are 8 sides, yes? Okay, now, you tell me, what operation do we have that is known to make multiple additions much easier? When you're doing repeated addition, you should switch over to using what? You should switch over to using multiplication. In which case, I would do 15 times 8. And that would give me the measurement of my what?
Octagon.
Of what about the octagon? Perimeter or area? Perimeter. Today is not about perimeter, but every day we talk about shapes, I'm going to talk about perimeter, so your brain keeps differentiating the two. Perimeter is always the distance what, the object? Around. Excellent. It's like you went on a little walk. You're a miniature little guy named Mr. Perimita. All the way around the stop sign. Perimeter. But today we're talking about area. So let's go back to area. All right, on this item, each side of the sign is 15 inches long. Yes, we discovered that. And measures 36 inches between the parallel sides. So guys, if we were to mark the measurement between parallel sides, it means pick any 2 sides that are opposite each other, yes? Do you agree the top of the sign and the bottom of the sign are lines that are parallel to each other? And they just gave you the information that if you went from top to bottom, it would be how many inches? Well, it said it would be 36. In the words right here, it said it would be 36 inches between those 2 parallel lines. So how many inches is it if I only go halfway? And they've marked this as well. What is it if I only go halfway? 18 inches. Do you agree 18 is half of 36, isn't it? Okay? So now that you know that, let's look at our next step. Decompose the octagon into what kind of triangles? Congruent. All right, so I need to erase the lines I had there, and I'm going to redraw lines so that they make triangles. So guys, give yourself a little center point, and then begin to make a triangle here. Yes, I should see people drawing. A triangle here, a triangle here, a triangle here. Are you making it? We're going to pretend that I made my dot exactly in the center. I'm not a machine, so it's probably not perfect. Definitely not perfect, just like all humans. All right, but do your best to create how many triangles? 8. You know how you can know that quickly? Because you have 8 bases of a triangle, don't you? Since this octagon has 8 sides, doesn't it therefore have 8 bases of triangles? And doesn't that therefore mean you have 8 triangles? Are you understanding this so far? Have you marked your 8 triangles? All right, so if I want to know the area of the whole stop sign, the area inside, not the perimeter, the area inside, raise your hand if you think you know what process I could use to find the area of all of the inside. Okay? Hold on, I've got a hand over here. Go. What would you multiply?
15 times 8.
Okay, now that would give you the perimeter that we talked about earlier. Remember, if we're trying to find the perimeter, we could do 15 times 8. There's something we need to find first before we multiply. So you're totally right that at some point we're going to multiply by 8. So great job on that. But what do you think we need to find first about one triangle before we multiply by 8?
The height.
We do need the height in order to find the,
Base.
we do need the base along with the height in order to find the area. Now I got people telling us, yay! Who said area? Wave at me. Awesome job, awesome job. Now out to the side, what am I finding the area of? A single what? Triangle. Write the formula for area of a triangle. Remember, you agreed earlier that it was A equals what? Well, base times height is a parallelogram or a rectangle. Remember, we cut the rectangle in half. So cut the formula in half. How can you cut a formula in half? By starting with 1/2, yes? Okay, so A equals what? 1/2 what?
H.
Let's do all the pieces. 1/2. Okay, remember the formula for parallelogram was A equals base times height. So A equals BH. We're just sticking a 1/2 in front of that. So A equals 1/2 BH. Thank you for the active participation. Everybody in this room, right? A equals 1/2 BH. Now that will give you the area of a single triangle. But if you want the area of the whole octagon, what would you then need to multiply that by? Multiply it by what? Say it. Multiply it by 8. So I'm going to tell you the truth. In a moment, when we start doing the very first item on your homework, you will be able to do this. First of all, do we know the area of this octagon? No, we don't know it. So draw a box under the A. Under the 1/2, what shall we write? 1/2. Under the B, what shall we write?
15.
Okay, the B was indeed 15 inches. So times 15. Under the H, what shall we write?
18.
Times, how tall was that height of the one triangle? 18. So isn't every triangle going to be 18 inches high? Yes. So 1/2 times 15 times 18. And then because there are 8 congruent triangles, the last item would be times 8. And if you put this entire thing into your online calculator, would it therefore give you the area, the correct area number for the entire stop sign? Yes. And when it does, since those were in units of inches, will this be in units of inches or inches squared? Inches squared. I hope this helps you for today's assignment.